Hi Year 12 Maths General students. This lesson is from Unit 3 of the Queensland Maths General syllabus, and we're looking at association and causation. So the lesson objectives today we'll be looking at, we're going to examine the reasoning behind the association between bivariate variables. So is one the cause for the other, or do we need to look at a new piece of terminology called spurious relationships and attribute the association we're seeing to common or coincidental reasons? And lastly, we're going to be investigating other potential explanations due to spurious confounding variables linked to both explanatory and response variables. Just because two variables show a strong correlation doesn't mean that one's necessarily the source or cause of the association observed. So it's potentially not a causal relationship. Sometimes the correlation that we see is just a coincidence or because of a third common variable linking the two variables being analysed. So far I've thrown a lot of confusing new terminology at you. So let's look at an example to try and clear this up. The example we're going to look at, we've got a strong association between the number of Nobel Prize winners a country has and the number of IKEA stores in that country. The correlation coefficient calculated for this association is 0.79. So that's a pretty strong positive value. The scatter plot that's been composed from the data collected, you can see here that we do see a fairly strong correlation between the number of IKEA stores and the number of Nobel Prize winners. So does that mean that for Australia to win more Nobel Prizes, should we build some more IKEA stores? In order to assess that question, we need to establish what we call causality. So is the explanatory variable the cause for what we see happening to the response variable? In science, when someone wants to validate scientific relationships between variables, a scientist will conduct multiple experiments to see the same patterns happening. Therefore, they can validate what they're seeing when changing the explanatory variable has a direct effect on the response variable. Each trial and their experiment always has a set of controlled parameters which are varied to test the effect on the results before proof of a relationship is established. So when we're conducting an investigation, all possible explanatory variables need to be controlled. So in other words, the conditions need to be kept the same. This helps give credibility to any association discovered between the variables we're investigating. Particularly if data is being collected through observation rather than experimentation, we must accept that strong association between two variables being analysed could possibly be insufficient evidence by itself to conclude that the variation we're seeing in the response variables has been caused by an observed variation in the explanatory variable. So we're questioning the causal relationship between the two. These alternative non-causal explanations are known as spurious relationships or spurious correlations. So to put that terminology really simply, it's possible that two or more variables can be strongly associated but not causally related. And the common reasons why is either coincidental relationship or there's a presence of a certain third unseen factor. And we refer to that as a common response variable. Another word is a confounding factor or a lurking variable. If we elaborate on what these spurious relationships mean, a common response correlation looks at explanatory and response variables being associated because they're both strongly associated to a third common variable that's known as a confounding or lurking variable. The other reason may be simply a coincidental correlation. So occasionally it's nearly impossible to identify any feasible confounding variables to explain a particular association, and a better explanation is its purely coincidental association between your variables. So if we come back to that strong association we observed between the number of Nobel Prize winners a country has and the number of IKEA stores in that country, hopefully you can see that this is simply a coincidental spurious correlation. Let's have a go at doing some examples. So we've got 3 examples here to have a think about. The first example talks about a strong positive association, so a correlation coefficient of 0.98 between the number of people wearing sunscreen and the number of people fainting. So does that mean applying sunscreen causes people to faint? Unless there's some sort of dodgy sunscreen manufacturer pumping out toxic sunscreen, this association is not very likely. So we can say almost certainly not. On hot sunny days, more people apply sunscreen and more people faint due to heat exhaustion. So both are related to a third confounding variable in terms of hot weather being the cause for both the increase in people wearing sunscreen and people fainting. Have a read through the second example, press pause and see if you can assess the situation this time. How did you go? I said, to allege that ice cream sales cause drowning or vice versa would not be a reasonable causal relationship between the 2 variables. In reality, a heat wave may have caused both variables to increase. So again, the heat wave is an example of a hidden or unseen variable, also known as your confounding variable. Okay, let's look at a different example that doesn't involve heat waves. The third one is looking at a scenario where a strong positive association between the number of people who consume margarine and the divorce rate in Australia is apparent, with a correlation coefficient of 0.77. So that's pretty strong. Explain why this scenario could be a causal relationship confounded by a third common variable, or alternatively could just be coincidental. What do you think? Press pause and write down your analysis of the scenario. Checking in, I said it's almost certain that this association is just coincidental. Simply eating margarine could not possibly cause people in Australia to divorce. This seems very unreasonable. I mean, unless one of the couple consistently ate the last of the margarine and didn't replace it, maybe that could be the cause of the fights that led to divorce. But this is hardly likely. Okay, so the take-home message is when you're analysing data for any scenario looking for potential association, always ask yourself the following questions. Can you eliminate all other potential causes for the variations in the response variable? Or is it clear that the explanatory variable is the cause for the changes you're seeing? Are there any possible common confounding variables at play here that could be linked to both your explanatory and response variable? And this third confounding variable is responsible for the variations you see in both your explanatory and response variable. Lastly, could the association just be a coincidence? Because there's no obvious logical or scientific link between the 2 variables being analysed. I hope this has helped with your understanding of association and causation. Thanks, Year 12s.